a little start on practicing Turkish. Nisancioglu is the last name, but I'm grown up. I grew up in Norway, but half Turkish. And as Jostein said, I think I met a lot of you, but I'm sitting at the Department of Earth Science here in Bergen and the Bjerknes Center for Climate Research. And I'm going to talk to you a little bit about this course or project, or it's a field course, adventure, as we might call it, that we start with this fall on the tall ship Statsraad Lehmkuhl. And I very much appreciate you just stop me or ask questions in the chat if you have something, and we can talk instead of me talking all the time. It's actually a formal course at UIB, SDG313. It is part of now the sustainable development courses that we have, I think 10 at the University of Bergen, that are supposed to be across faculties and institutes and offer teaching related to the Sustainable Development Goals and Agenda 2030. I'll tell you a little bit about that. But it came out of the regular course that's called Causes and Consequences of Climate Change, and now turned more into Causes, Consequences, and Solutions of Climate Change. And this course is kind of a field component to that, although which is starting, so we don't know really where it goes. And I could also mention that SDG313, that's you see on this slide, also is a teacher version of this course in Norwegian that's also been developed, and it's part of a DQ project. And I think I talked about that some weeks ago or months ago, before the summer, probably early this year. So they're all connected, but they're all different. Yeah, it all comes out of this. You might know this, an online course we started to make 2014-15. And it's been running ever since online. So it's a lot of what comes of the science and the teaching is related to the online course, and that's still running. And it actually has, it's running again this fall. It's mostly online or only online. A lot of this. So there's a lot of what we learned through that, and we're bringing with us. And what we didn't manage to do, which you all know, when you're in digital teaching, it's very hard to connect with the students and give them an experience and the feeling and understanding of some of the topics, some of the places, some of the impacts, for example, of climate change locally. That's what we want to do in this new course. I said that it's part of the Agenda 2030 adopted by the UN and all the UN member states, and in particular SDG 13 climate action. But it also touches on 14, 15, 17, 12, yeah, even that one, but 2, clean water, education, quality. And so it is a course at this point, this fall, where we include quite a lot of aspects and also discuss some of these sustainable development goals. Number 13, just to remind yourselves, that's the resilience and adaptive capacity to climate-related hazards and natural disasters, and then also to integrate climate change measures in policies and strategies and planning, and then improve education, awareness raising, and the capacity to mitigate and adapt, and also provide early warning. So a lot of these things are very relevant, and in particular relevant for a lot of these ocean states that we're going to be visiting on board this ship in the coming years, actually. So what we do, and very specific now to our course, it's a fall semester course, 5 credits, and it's taught in parallel between the University of Bergen, University of West Indies, and several US partners, and I'll show you who in a moment. And these are our colleagues in the University of West Indies. We have had monthly meetings with them over many years, actually. It's part of the Sustainable Development Collaboration of International Association of Universities under the UN. So Bergen is a partner in SDG 13 and is also the host of SDG 14, and organizing and coordinating an effort to strengthen teaching and education on those 2 development goals. So the ones who run this is particularly Stacey Kennedy, sits in Trinidad and Tobago, and there are lots of colleagues around in the University of West Indies as well as in other universities abroad, but it's coordinated by the University of West Indies. So this is the first time, and it's been a long-term goal that we would do a joint course. This is the first time we actually managed to do it because we have the ship, and also we do it virtually, but we'll be meeting physically as well in November this year. So these are international partners in addition to University of West Indies. So it's Fiamma, Natalia, David, Patrick, Jake, Peter, Michelle, from some of the most well, prestigious, what should we call it, universities in North America. Very exciting science represented by a lot of these colleagues that we then can include because we have the opportunity to meet virtually and then eventually in a more intensive field component at the end of the course. They all have different expertise. I won't go through these, but the learning goals are to include the concepts and understanding of key oceanographic and meteorological concepts, also understand storm surges, hurricanes, extreme weather, and threats posed by these, also understand the impacts and the challenges related to marine ecosystems and in the face of climate change, and so assess and evaluate or understand, recognize the human impacts of climate change and the risks related to this. And then also ocean pollution and ocean transports, how these are affecting local communities, and then of course engage with the sustainable development goals. These are the general learning goals of our course. And then we have more specific things, and I'll rather show you examples rather than go through this. So what we do now is that we've started, maybe have a different slide that's more useful for you. Oh, that's really small. We basically have and started 1st of September with webinars, weekly webinars between our university campuses. And that's been a challenge because some are sitting in California, some are sitting in Jamaica, and some are sitting in Bergen, but it's doable. So we have Sunniva is coordinating this. Actually, she's employed part-time to help with this and been part of the helping this course. Sunniva Rutledal, she maybe is online, I don't know. And so we have weekly webinars, 4 to 6 every week. And we have then key topics, key talks from our partners from all of these universities. And then in November, 8th of November, we'll go on board for 3 weeks and then be field-based activities. So the students are preparing now, working on research projects, defining what they want to do on board. And then once we get on board, it will be a hectic 3 weeks with hands-on activities and presentations and sharing of knowledge. This is the seminar schedule, and I can't, yeah. It's been posted to iEarth, so you can look into it. So that we had some really exciting talks. The first one was Nimo Bassi. That's a fantastic, very inspirational talk by the Rafto Prize winner, laureate 2012. So he's basically one of the people representing local communities fight for justice for human rights in the Niger Delta in face of grave natural and environmental changes due to oil exploration in the region. And he's been, a voice from Africa for many years. So he was the first one out in our seminar series, giving kind of the perspective of health and food and security and the threats of climate change, and also a bit on climate action, climate like in the face of, for him also the challenge of human rights violations locally. So that was something very different from the type of geosciences, natural science world we live in, but very inspirational for our students to see also why our science is important and for who and how it's received or taken on by local communities. And then we went on to Michelle. Actually, it was Jake Gebby first, but I'll come to him last, but I won't go through all the talks. But Michelle, she's a lecturer at Stanford and working at the Blue Food Project, which some of you might have heard about. I didn't know much about this, but it's fantastic. There's a series of 4 or 5 papers in Nature this year, where they go through key topics related to food security, environmental and climatic impacts of foods and land use changes, marine resources in particular, which I recommend all of you read. This is one figure from that, just to give you a perspective of the different topics in this course. It's basically looking at the nutritional value and also, not in this one, but the climatic impacts is part of this, of different fish foods. And it shows that, for example, bivalves and then small fish are very good. We should eat more of that. And then less so for some of the larger fish. For example, cod is not very good. And then there's, just to understand what are the challenges in feeding the population, how does this, what we eat, impact climate change, and also how what we eat impacts the environment and vice versa. So that's the 2 first lectures. And now last one is Jake Gebby, who some of you know. He works at Woods Hole, more on the physical oceanographer, working on also paleoceanographic topics. And this one is part of the projects we're working on. Michelle's will also be a project. And this one with Jake Gibby, it's a project that students will work on. That's basically the historic changes in ocean temperature through time, and how we know what the temperature and the ocean climate looked like before the Industrial Revolution 150 years ago. So it's going back to the HMS Challenger expedition, and that's what is quite exciting with this, is that we are on a ship that looks a bit like the HMS Challenger. It's only 100 years old. HMS Challenger was 150 years ago old. It spent 3 years going around the world. We were going to spend 1.5 years, not us, but the boat, almost 18 months. So there's some parallels. Plus, we have the opportunity to cross some of the paths of this. Start of the modern oceanography was done during HMS Challenger, so we can repeat and teach and understand some of the challenges of doing measurements in the ocean. Okay, so these are the projects. So the students now have webinars, but each week they have 1 hour where they work on the projects together with mentors, now more and more autonomously, so that they have a webinar, we talk together a little bit, then they go off for an hour, and then they meet more often also without us as mentors to work on the projects. And then they'll present them to each other actually next week, and then again more formally on the boat with kind of the results. So the 4 projects are historical ocean data, coastal flooding, sea level, hurricanes, atmosphere-ocean interactions, and marine resources and ocean transport. So these are all key components of climate and the impacts of climate, in particular locally in the Caribbean. So I'll get back to that. I forgot where the boat, tell you where the boat is going, but it's going to the Caribbean. We also are focused on climate adaptation and sustainable solutions. So first, a little bit about Challenger, and then I'll show you where the boat is going. So the Challenger expedition was 1872 to 1876. It was actually I think it was the University of Edinburgh who instigated this big endeavor to chart, measure, understand the climate of the marine, the state of the ocean, basically. So they spent 3 years, 4 years going around the oceans, doing an enormous amount of work, measuring ocean hydrography, temperature, salinity, doing a lot of sampling for marine organisms. So it's been an immense effort, and it's actually been instrumental in our understanding of how ocean has changed and how the ocean state was like before humans made a big impact through industrialization. And also the Nansen referred a lot, if you read his books, to the HMS Challenger expedition, and compared a lot of these then later big scientific expeditions, oceanographic expeditions. They all had HMS Challenger as the baseline. So what we're going to use is the HMS Challenger kind of as a baseline, but at the same time, we're going to try to repeat some of the measurements and look at what are the areas, the challenges with these type of oceanographic, traditional ways of doing oceanographic measurements, because this max-min thermometers they used, this picture is maybe not the best one. They were actually encased in a copper tube, but there are these Miller-Casella thermometers, and they were used to measure temperature, and they had to go up and on, up and on, and up and on each time they did the measurement. But fortunately, temperature was monotonously decreasing down, so they can measure temperature very accurately with a very good instrumental error was insignificant. So the big challenge here was actually the rope. They used hemp ropes with these thermometers, and those stretch, they move with the currents, they behave in the way the rope behaves. So it's quite tough to actually know at what depth you are. And of course, you have the boat that's moving at the same time. So there's been several efforts to try to calibrate these, and Jake Gibby and Peter Hoivers and others. Now there's a big effort actually ongoing in the US to calibrate these measurements by knowing exactly how deep the ocean is and that they met the ocean floor at that point they were. We can calibrate to some degree, but not perfectly. So what we're going to do is actually use the hemp rope. We've now, the Fartøyvernsenteret in Norheimsen has made 1,000 meters, or soon at 1,000 meters long hemp rope for us. And we have some old thermometers that we salvaged that we're going to bring with us. And then with the students do this measurement again with CTDs on the rope, and then also with thermometers, just for illustration, for learning to understand the challenge of measuring in the oceanographic context 150 years ago, when we were on the boat sailing in the Caribbean and across the Atlantic, and at the start of the Gulf Stream. Oh yeah, and then one of the exciting things with this prospect is that if you look into the ocean today, the ocean water in the Pacific that's upwelling today, is more than, well, it's 1,000 years old and even older. So you will find water from the Little Ice Age, and you will find water from the medieval warm period even. That's mostly gone, but you find water from the Little Ice Age in the Pacific. Actually, in the Pacific, you will even find water from the medieval warm period. This is a plot of ocean temperature in the Atlantic over the last 2,000 years. And there you can see this this is actually from a model, but it's tuned with the HMS Challenger data and modern data. And you can see the red blob here is the depths, how the medieval warm period water history is preserved by the deep ocean as it ventilates and as it's moved with the deep currents to the Southern Ocean and then into the Pacific. So you find this water today. We'll find Atlantic Ice Age water, really old water today, and even here, if you go at depth in the Atlantic. So the question is, how old is the water in the Caribbean? Where we're going, we'll see. There's some really deep basins there. And then next year, when the boat goes to the Pacific, we'll be able to find some of the really old water. And that's, of course, something exciting for the students to experience. And I think we're going to do this. So that before I forget it, one of our goals is actually not just to do this year and next year where we have the Statsraad Lehmkuhl, but perhaps or hopefully do this every year with students on the tall ship or a smaller ship, because we have the opportunity in Bergen to get out on sea. We don't only need to use the big expensive diesel powered research vessels. We can also do some of this with sailing vessels with our students. I think it's a better learning experience also in a lot of cases. Okay, so this is the boat. We go to sea after these webinars this fall. We also have webinars. The webinars also include our colleagues in the University of West Indies on local Caribbean oceanography and paleoceanography. And then we go on board and meet together. Starting 6th of October, we fly to Curaçao, and then we have a stop in Kingston, Jamaica with the ship. And then we land in Cuba, and most of the students will continue to Nassau. And that's partly because it's easier to go from Nassau to US than from Cuba to US, which is not possible. For Europeans, it's actually easier to go from Cuba to Norway. So Nassau was actually really expensive, but that's a different story. Logistics has been a pain. COVID has been really difficult, but the embassy in Cuba who are hosting us have been extremely helpful. So there's a big team of people helping us with the logistics of this expedition. This is what the boat looks like underneath. There's a fantastic classroom. Some of you might have been there. It's been refurbished over the summer. So you can fit 30 people below deck with the screen and everything, but most people will be seasick in the beginning, my bet. So we'll be doing hands-on projects on deck where they work in groups, and it doesn't depend on sitting on the deck in the classroom. We'll rather do this type of teaching. This is me and my colleagues from Bjerknes Center doing our Klima Seilas to Arendal a couple of years ago, which was a fantastic experience where we had a whole ship with the group projects, discussions, networking, bit of science like this on deck for 3 days. So we have a kind of a taste of what's possible, and it's an incredible platform for teaching. So, and also the sailors will sail. That means all the students will sail, otherwise we won't move. So it's a huge ship. You need 60 people to sail it. So that means everybody has to work 4 hours per day. Maybe not completely 4 hours, but almost 4 hours per day sailing. So that will be exciting for everybody. It's highly modern. It's actually a very sophisticated research vessel by now, Statsraad Lehmkuhl. It has all the modern instrumentations. Of course, echo sounder, ferry box, CO2, oxygen, pH, DNA, wave sensor, weather station. It sends and receives all the data continuously through help from Kongsberg. So there's a satellite link, so you can see the data in real time already today. It has automatic CTD that goes down. Well, it's a 1,000-meter cable, so let's say 400 meters maybe, continuously up and down, hydrophones, and you name it. So it's impressive, and we'll be able to use and integrate this data in our teaching. So the students are already looking into this, and will hopefully be able to download and work with the data in the coming months before we go on board. And then when we get there, we'll be using this data and calibrating also our hemp rope measurements, handmade measurements, old style. There's a continuous, just for those of you who don't know what the OneOcean expedition is, it is a partnership with many institutions, including University of Bergen, who is a big partner. So we have it this fall for 3 weeks with students. Next year, 4 months with 90 students. So this year, only 30 students. Next year, 90 students on board for 4 months. And then it's in the Pacific, and I'm also involved there. But then it's a collaboration with the University of Pacific, South Pacific, sorry, University of South Pacific. But continuously on board, there will be 2 math students who are working with the instruments. This is actually Erik Furuvik. He's at NTNU, but now there are UIB students there. One of my course participants, Nelly, will be on board starting tomorrow. So we'll get updates along the way. And there will be students continuously on the boat for 18 months, I think about a month each, in running the instruments. So there's a pretty advanced, like I said, instrumentation that needs to be maintained. And you'll see really nice blog posts online at OneOcean to understand what is being done on board. There's no teaching now, right? Because the teaching will be the first ones actually bringing students aboard, but the measurements are being done continuously. This is the ferry box, as far as I know. But of course, the challenge, wind, weather, we're hopefully at the end of the hurricane season. Part of our topic is hurricanes. The ship is well accustomed to any weather, North Sea, wherever it has been all over the world. So this is a crew that's extremely, extremely skilled. But of course, that will be a challenge like on any oceanographic expedition. But we'll hopefully get a lot out of it, all of us who are on board. So with that, I don't think I had any more. No. So those were the slides I had. So questions, comments, ideas, recommendations are very welcome. Is there anybody out there? Oh, I have a nice background that has nothing to do with the ocean.
Yeah, hi Kerim, this is Stefan.
Hey, Stefan.
Hi, great talk, really, really interesting. I just had a quick question about the sort of redoing the measurements with the hemp ropes. I realized that from what you said, you're going to places where you know sort of where the bathymetry is or where the water column is and all this. I just wonder, are there sort of modern instruments that you can put in addition to these old instruments to get ground truth at the same time, sort of more like the position or the depth? And is that something you use?
Exactly, yeah. So that's exactly that I brushed over it a bit quickly. So thanks, Stefan. So the plan is actually to put the CTD on the hemp rope. So we'll use that and calibrate in terms of, then we have the exact depths or pretty good depths with the pressure sensor and an accurate temperature and then salinity at the same time. And then we're using the thermometers more as a teaching tool, right? That the students will actually be also experiencing how they did these measurements. Then we'll take many days to do one cast, right? Compared to the CTD that just goes down and up once. And you have the depth, you have the measurements continuously. Okay. So, and at the same time, we can use the hemp rope with the automated CTD. So we can maybe hopefully do a bit more measurements, but those won't be very deep. So we don't know yet what's realistic, but definitely we'll use the hemp rope with the lightweight CTD, and then also with different trial and error, see how we can get as close as possible to the original measurements. It doesn't have to be at the same spot, right? At some point we'll do that also, but for now it's to test the technique and get familiar with using this type of rope, and then we'll repeat it, maybe not this winter, but next year.
I see. Oh, that's cool. So that's basically going to be parallel sets of data sets.
Exactly, yeah.
Look at in comparison, basically.
Yeah, so Jake is super excited about this, and you know him well, and Peter. So it's one of our really unique opportunities to really spend some time on trying to understand and calibrate this data. There are fairly big errors on the depths in particular, not the temperature, but if your depth is wrong, and there are some issues with that, right, then it's a bit hard to use the data. But they're being used quite heavily, actually, these data today. So they are very important for us. So that's what I understand from there. A few papers, even one recently this last month on the salinity from HMS Challenger in Nature. So there's a lot of interest in this.
So basically, that could lead to basically a group paper. You could involve the students in an important that could then be used by many people.
Exactly. So they know that. So as you know, this is part of what started as the ACDC summer school. So each school has 1 or 2 papers by the students, led by the students in the last year. So there are, I don't know, I lost count how many papers in total. So those are student-led projects that start like this, and then they continue work maybe for a year, half a year together afterwards, and turn into some really exciting science.
It's very cool. Thanks, Kerim.
Mm. And there's a question for you. Oh yeah, go for it.
No, I was just seeing if there were more questions.
Because I actually have a question for everybody, unless someone wants to ask me, but I would want to know if people think it's a good idea to start using these sailing ships for our students. And we are actually going to try, with Sunniva's help, hopefully, maybe we can do a sediment core. I've done that on small ships, and some of you have lots of experience on this, right? It's difficult, but it could be also fun. So you can do a lot of science that's very educational. With very little CO2 imprint if you stay offshore Norway and don't fly to the Caribbean. I can explain to you why we're going there, but that has to do with the impacts of climate change, hurricanes, sea level, storm surges. But that motivation is strong, but you can't do that every year.
Yeah, so the next project would be to go with Gurine to the northeast or northwest passage, right?
Yeah. So, okay, good you mentioned it. So I don't have a picture, but Gurine is the sister ship of Gjøa. It's 1874 it was built, I think. It's from Rosendal. And we've talked to the crew to actually use this. That's a smaller boat, but we can bring on board, on deck, maybe 40, but on the deck, max 20, maybe less. And they really want to go into the Arctic. And that was a bit more modernized instrumentation, reversing thermometers, Nansen bottles. Again, really, really interesting for students to be part of, to do these type of measurements and repeat kind of the footsteps of Nansen, Amundsen, Helen Hansen, and everybody after that.
Okay, any other comments or questions to Kerim? No? Okay, but then